So, if you've been keeping an eye on what's going on inside our computers, you've definitely heard of the CPU and the GPU. But lately, there's a new kid on the block, the NPU. In this explainer, we're going to break down exactly what this new chip does, how its brain is wired, and what makes it so fundamentally different from the processors we already know and love.
And that is the perfect question to start with. I mean, for decades, the CPU and GPU have been this incredible power couple in computing, right? They've handled pretty much everything we could throw at them. So why now? Why do we suddenly need a new player on the team? What kind of job opened up that required a completely new kind of silicon brain?
Well, to really get why this new specialist is such a big deal, we got to take a quick look back at the original team members. It all boils down to how they're designed to think.
Let's think about it this way. The CPU is like a world-class master chef. It's a total genius at following a long, incredibly complex recipe, one precise step at a time. The GPU, though, it's more like a massive army of line cooks, all chopping carrots at the exact same moment. It's built for thousands of simple, parallel jobs, which is absolutely perfect for painting the millions of pixels on your screen.
And this setup? It worked great for years. The general manager and the artist, they could handle almost anything. But a new kind of work started to pop up, something that didn't really fit either of their job descriptions.
And that new challenge, as you've probably guessed, was artificial intelligence. Specifically, the challenge of running these really complex AI models right there on our own devices.
You see, the thing about AI, the process of it making a prediction, involves this just mind-boggling amount of very specific, very repetitive math. Our master chef, the CPU, was just way too slow trying to do it one step at a time. And the GPU, our army of cooks, well, yeah, it could power through it, but it was incredibly power-hungry. Total overkill. It was kind of like using a fire hose to water a houseplant.
So, the industry needed a new hire. It needed a purpose-built processor designed from the ground up to be the team's dedicated AI Brainiac. And that is the Neural Processing Unit, or NPU. It's not a generalist trying to learn a new trick. Nope. Its entire reason for being is to run AI and machine learning tasks as efficiently, as humanly, or siliconly possible.
This quote really just hits the nail on the head. A GPU is amazingly versatile, a talented generalist for sure. But an NPU, it basically throws away everything that isn't AI so that it can become absolutely exceptional at that one single job. The real question is, how on earth does it do that?
The NPU's big advantage isn't just about being fast, it's about a totally different design philosophy. It's literally wired differently. And this is where things get really fascinating. Instead of just trying to cram more power onto a chip, NPU designers look to the human brain for inspiration. They're built to mimic biological neurons, creating a system where the smooth flow of information is actually more important than just raw clock speed.
Now, they pull this off in a few key ways. First, NPUs have special hardware for the core math of AI, something called multiply-accumulate, baked right into the silicon. Second, they have super-fast memory right there on the chip, so data doesn't have to travel far. That gets rid of a huge bottleneck. And finally, they use something called a spatial data flow architecture, where data moves through these dedicated pathways, almost like a perfect assembly line, that's perfectly matched to how an AI model actually thinks.
I love this analogy because it makes the difference so clear. Using a GPU for AI is like trying to turn an old warehouse into apartments. Sure, you can do it, but it's not going to be perfect. An NPU, on the other hand, is like a brand new apartment building, designed from the very first blueprint just for living in. Every single choice is optimized for that one job.
Okay, so the technology is seriously cool. But what does having this new AI Brainiac on the team actually mean for you, for me, in our daily lives?
The key here is something called heterogeneous computing, which is just a fancy way of saying these processors don't compete, they collaborate. The software is smart enough to give the right job to the right specialist. The CPU handles the operating system, the GPU takes care of the beautiful graphics, and the NPU, it gets all the dedicated AI work.
And the difference this teamwork makes is, well, it's staggering. To run the exact same AI task, a GPU might burn through 30, maybe even 50 watts of power. The NPU does the same job using just single-digit watts. That's not just an improvement, it's a complete game changer in efficiency.
So what does all that efficiency actually get you? Well, first off, faster and much more private AI. Things like real-time translation or blurring your background on a video call can happen right there on your device. No need to send your data to the cloud.
Second, and this is the big one, dramatically better battery life. And third, everything just feels smoother because the CPU and GPU are now free to do what they do best.
So it's really important to remember this. The NPU isn't here to replace the GPU or the CPU. It's the highly focused specialist that completes the team, letting the entire system work way smarter, not just harder. And that brings us to a final, pretty powerful thought. For the first time ever, really high-performance AI is becoming a standard feature on the devices we carry with us every day, all while just sipping power. This isn't just another upgrade, it's a totally new capability. So the question is no longer if we can run powerful AI locally. The real question is, with these dedicated AI brains in our pockets, what monumental problems will we choose to solve?